Welcome back to our class. Today we are going to be looking at the nomenclature, reactions, and physical properties of organic chemistry. But in this regard, we are going to be looking at the questions, the expected questions in this nomenclature, reactions, and physical properties. Let me know if you have any question concerning about this so that we can tackle it and then we try to answer that question as we go on. It is M.SAIDI as usual. So let's start without wasting time. The first question we would like to know is going to be about naming. How do we name these organic compounds? So the moment we know how to name, then we'll be able to go to different questions concerning about the reactions. I know that reactions are very difficult for students. And then after that, we shall go to the properties, and then we see the most likely asked question in this section. As I told you that yesterday, that this, once you get organic chemistry, you are able to get a distinction. Yes, because all people who are getting distinctions, they start with organic chemistry. All right, let's start without wasting time. I've organized some questions here. The first question is like this. Yes, the first question is like that. They are saying that consider the reaction or the organic compounds represented by letters A to F in the table below. You have A, B, C, and D. Write down the letter that represents number 1, the aldehyde. How do you know that this is an aldehyde? So based on this, it means that you have to use what we call the general formula to know what is the aldehyde. Remember, we said that aldehydes and the ketones, they have the general formula. They have the same general formula. So it means that you are able to get those formulas as we said it yesterday. We said that the general formula for, we said this starts with N to N. But because it is an aldehyde and the ketone, so they have the O there. Why? Because the hydrogens have been replaced with the oxygen. Therefore, now if you look at these compounds, which one falls in that general formula? So the first one to look at, let me just check something here. The sound, yeah, think now it is perfect. If you are not hearing properly, let me know so that I can sort that out. Yes, I can sort that out. I think now I'm clear. All right. Here you have C. We say that you have C N H 2 N O. So if this is 1, 2, 3, 4, 5, yes, if it's 1, 2, 3, 4, 5, so it is 5. So it is 5 for N times 2, which is 10. Let's look at it. 3 plus 2 is 5, plus 2 is 7, plus 2, it is 9, plus 1, it is 10. So it is 10 hydrogen, 5 carbons, 1, 2, 3, 4, 5, and 1 oxygen. So this one qualifies. When we come to this, no oxygen is out. When we come to this, no oxygen, it's out. When we come to this, it is they're saying which one of the following represents number 1, they are saying aldehyde. So also this corresponds to this general formula, but they are saying aldehyde, not ketone. Remember, when you say on, it is a ketone, because when you say ketone 1, this 1, so whenever you see the word 1, it means a ketone. Therefore, the answer is gonna be B. So this is the most correct answer for this. I think I'm clear. Yes. Then we go to the second equation. Yes, we go to the second equation. Saying that compound which has a carbonyl group bonded to 2 carbon atoms as its functional group. Yes, compound that has a carbonyl group bonded to 2 carbon atoms as its functional group. All right. When you say carbonyl compound, yes, what does it mean? Yes, what does it mean? Compound that has a carbonyl group bonded to 2 carbon atoms as its. Remember that the carbon atom with the carbonyl group, meaning that we are talking about the same compound, this or this, but is bonded to 2 carbon atoms as compound which has carbonyl group bonded to 2 carbon atoms as its functional group. So it means that they're saying that you have the carbon atom, the carbonyl group is this, but it is bonded to one carbon atom and another carbon atom. You understand? Yes, it is one carbon atom and then another carbon atom. That's what they are looking at. So the answer becomes D. Yes. Some parts are missing, because here in the question also they say that A to F. They are saying that write down IUPAC name of compound C. Compound C. So if you look at compound C, what are you going to say? When you look at compound C, it is 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you have to first identify the longest chain. So in this case, it's gonna be like that. That is the longest chain. So if that is the longest chain, then it means that is going to be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. That is in that direction. Or carbon 1, carbon 2, carbon 3, carbon 4, carbon 5 in that direction. So now you have these halogens. So we have to take the shortest or the simplest, the one which has the simplest number. So it's 1, 2. So the first one is on carbon atom number 2, the second one on carbon atom number 3. But if you come this side is 1, 2, 3. The first one is carbon atom number 3, the second one is carbon atom number 4. So it means that we're going to take that direction. So it means that the answer is going to be, so the longest chain is 1, 2, 3, 4, 5. So it's gonna be pentane because it has no double bond anyway. Then I don't stop there. Now I need to know the side groups because this, and this are substituents. All right, so I have the bromine, have the chlorine, and I have the methane, this one, because we didn't count it. So it means that it's going to be 1, 2, 3, 4. You see? So it's going to be on carbon atom number 4. So it means that this means that I'm going to count by saying this one means bromo, this one means chloro, this one means methyl. So now I can now start labeling. So we say that it is pentane, yes. If you look at it, it's pentane. And then the first group is on bromine, which is carbon atom number 2. So it's going to be 2 bromo. The second one is chlorine, so it's going to be 3 chloro, 3 chloro. It's going to be 3 chloro, sorry, chloro. And then the fourth one is gonna be methyl. See, this methyl is also side group because we counted this as a straight chain. So this is a branch, or you can even say this is a straight chain. This one becomes a branch. It's the same thing. So it becomes 4 methyl. Yes, because if used the other way, it's gonna be 1, 2, 2 methyl. Yes, 3 chloro, yes, and then you talk about 4 bromo. But because this is the halogen, a halogen, or a halide, a compound which has a group 7 element, what make them to react are the group 7 elements. So it means that we take them to be as the functional group. Therefore, we start with the side which has the functional group. Yes. Therefore, it means that in that regard, I'm gonna have, what am I going to have? I'm gonna have, I come back here and I say, now, since I have identified the positions, now I need to use what called the alphabetical order to arrange them in their order. B, C, M. Which one is first in alphabet? The one which is first is the one which I'm going to start with the writing. So it's going to be bromine. B is before C, C is before M. Actually, they're in their order. So it's going to be 2 bromo dash 3 dash chloro, yes, dash 4 dash methyl. Meth means 1 carbon atom, as you see it here. But once you add the word YL, the moment you add YL, it means that it means that it is a side group. So that's why here we said that we have said that it is methyl. So it is 4-methyl pentane. 2 bromo, so it means that it is 2 bromo, 2 chloro, 2 bromo, 3 chloro, 4 methyl, then the longest chain, which is pentane. I think I'm clear there. Any question? If you have any question, let me know before I continue to the next question. Then they are saying that write down the IUPAC name of compound C. We are done with that, compound C. Write down the structure formula, of compound A. Where is compound A? Now it means that we are supposed to write the structure formula of this compound. Let me clear here so that it is easy for us to write. So it is 2,2-di-2,2,4 trimethyl hexane. 2,2,2 is, they said, is 2,2,4 tri methyl what? Methyl, trimethyl, where is it? Trimethyl, hexane. Yes. All right, now let's start. This means alkane. So single bond. This means hexagon. 6 sides, 6. This YL means a side group. Ne? Meth means one carbon atom. Tri means 3 substituent or 3 branches. Yes, the first branch is on carbon atom number 4, the second branch on carbon atom number 2, and the third branch is on carbon atom number 2. I think I've explained what it means. So before you write this structure formula, you need to know, you need to identify what it means, each and everything. So now let's go to the writing, and then we find out how do we write this. All right, so we are saying that, we say that alkane, it means a single bond throughout. So I'm gonna say, and there are 6 of them. So I'm saying 1, 2, 3, 4, 5, 6. Don't forget that each carbon atom is supposed to have 4 bonds. Why? Because it is found in group 4. Yes. So if it is in group 4, it means that is remaining with the 4 bonds to, or 4 electrons to become a noble gas, or group 8. Or it can lose those 4 electrons to still to go back to become a positively charged, and still it goes to the state of noble gas. All right. Now, all this blank thing means there is hydrogen until we put something there. All right, but in exam, please don't leave them hanging, because we'll cross it. We want with the hydrogens there. I'm just doing this so that I'm just so that I can finish up all the questions. All right, then they're saying that is 4. So now the first, they are saying that they are methyls. The first one is on carbon atom number 2, carbon atom number 2, carbon atom number. So if I count this from this side, 1, 2. So I put a methyl there. I put another methyl there because they said on the second one still is a methyl. Yes. On the fourth one, there is also another one. 1, 2. So now I don't come from this side. I continue. 1, 2, 3. Yes. 4. Still I have a methyl here. But each of them, they must have the hydrogens. So I've talked about this. We said these are side groups. We have seen them, and the meth, which means that with the 1 carbon atom, yes. And then now it's hex, meaning there's 6 of them. The parent chain, 1, 2, 3, 4, 5, 6 sharp, and then they're saying that alkane, it is ANE. Remember that means alkane. Hence, it is 1, 2, 3, 4, 5, 6 single bond throughout. Hence, the structure is being written like that. Fill this with the hydrogens. Please don't forget that. Please take note of this, that whenever you see this, you have to see that each carbon atom has 4 bonds. If you short them, you'll get it wrong. Yes, you'll get it wrong without any story, without anything to become excused. All right, let's continue. Let's go to the next question. Next question, they are saying that Write down the structure formula of compound A. We have seen it. Now write down the structure formula of compound D. Pentan 2-on. Pentan 2-on. What does it mean? It's simple. So it means that I just come here. Okay, even I can write it here. Let me just do like this. Yes. All right. So it's gonna be pent. Pent means 5. 2 is the position of the functional group, and then on means it's a ketone. It means that it is along the molecule. So it's 5. 1, 2, 3, 4, 5. So it is on carbon atom number 2. If I count from this side or this side, whatever, you put it on carbon atom number 2. Yes. Then now you fill the hydrogen, the carbon with the hydrogen, 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 hydrogen. 1, 2, 3, 4. Yes. 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 1, 2, 3. Sorry. Yeah. So that's what it means. 4, 4, 4. So it means that you fill in with the hydrogens, hydrogens, hydrogen. So that is pent 2-on. That is what it means. Then the next question, they are saying that the table contains compounds which are functional isomers. What are functional isomers? Now they are talking about what are functional isomers. Did they? Oh, they even asked the question. Functional isomers, these are molecules or compound with the same molecular formula but different functional group. Examples in our grade, based on our grade, include aldehydes of the same number of carbon atoms and ketones, then esters and carboxylic acids. You understand? Of the same number of carbon atoms. Then also, we don't talk about it, but if you're a university student, alcohols go with ethers. Ethers. So we don't talk about ethers on grade 11 level. So we only talk about alcohol. No. We only talk about ketones and the aldehydes, and then carboxylic acids and the esters. Yes. So we say that these are compounds with the same molecular formula but different functional group. Yes. So they have different functional group. Like if you look at the esters and the carboxylic acid, they have different functional group. If you look at the ketones and the aldehydes, they also have different functional groups. So you cannot go to the paper without knowing what are isomers. Remember, we have what called the chain isomer. It means that the same structure, same molecular formula is the same. They start with the same molecular formula, but what they ask you if it's chain isomer but different chains. Same molecular formula but different functional group. It means that it's a functional isomer. Same molecular formula but different. So if it is a chain, so it's linked to chain. If it is a functional isomer, then it is linked to the functional group. You understand? Yes. So all of them are regarded as structural isomers. Yes. Basically, chain isomer are examples of structural isomers. So please don't let yourself down. Don't let yourself down, as it can be chain isomer, positional isomer, or functional isomer. All right, let's continue to the next question. The next question, they're saying that write down the letter that represent the compound that are functional isomers. So it means that here we have to look at compounds which are functional isomers. Based on this, yes, based on this, the answer is going to be B. Let's count it. 1, 2, 3, 4, 5. Remember we said that this is an aldehyde. So it is pentanal. Yes, but this one is pentantuol. So it means that this is a ketone. Remember I said that as long as they have the same number of carbon atoms, therefore we call them isomers, ketones and aldehydes. So the answer for this case is going to be B. It's going to be B and D. Think I'm clear there. Then we go to the next question. The next question, yes, each question is designed to have different aspects is supposed to cover. That's why I brought them just to show you some few samples of these questions so that you don't get lost. And they are saying that the table below A to F in the table, the letters A to F in the table represents 6 organic compounds. Then they are saying that name the functional group of compound B. What is the functional group of compound B? So this is methyl butanoic acid. Listen, this is not an ester. No, not because it is a carboxylic acid, but with a side group. So the functional group here is carboxyl group. Is carboxyl group. Yes. So that is the functional group. Homologous series, those are carboxylic acids. So please don't confuse homologous series with the functional group. Carboxyl group, but the homologous series is homologous series it is carboxylic acids. All right. The homologous series to which C belong. Name the functional group. Yes, we are done with that. They are saying that the homologous series to which C belong. Where does C belong? Sorry. C is in, they are looking for the now homologous series, not the functional group. Ne? Because we have the formyl and carbonyl. Those are homologous series for ketones and for aldehydes and ketones. But homologous series, we have the ketones and aldehyde. Formyl and the carbonyls, those are functional group. Yes, but the homologous series is aldehyde and ketones. So in this case, what are they looking for? They are looking for the homologous series. So this one is going to be a keton. Keton. It's a keton. So that is the answer. You are supposed to check yourself and see that if this paper comes whenever you write it or you wrote it, will you be able to answer these questions? Yes. If you won't be able to answer those questions, please try to read more and more and more so that at least you get it. They are saying that write down the IUPAC name of compound C. Now I want to see compound C. Where is compound C? This is compound C. Still is the same compound. So they want us to write the IUPAC name for that compound. So now we need to know how many carbon atoms are there. How many carbon atoms are there? Compound C is this. Let me rub off so that I write it clearly. You see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I see. This one is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So it means that this becomes a side group because the longest chain, I told you that doesn't mean that because it is bending, then it's not the longest chain. As I gave you an example that if you sleep on the bed when you are straight, does it mean that you become a different person when you sleep on the bed when you are bent, you're bending, or you bend your legs? No, you remain the same person. Yeah, so it's the same chain. It's just that this chain is bent. It's not a branch. Yes. So you count without stopping to go back. Then it becomes the chain. So now it's gonna be 1, 2, 3, 4, 5, 6. So 6 is hexane. Remember, as I told you yesterday, it goes up to there. And then because it is a ketone, so I'm gonna say on. But I need to know the position of on. 1, 2, 3. 1, 2, 3, 4. This one is 3, this one is 4. Therefore, I'm gonna go with the one which is the shortest, which is 3. So it's gonna be hexane 3 on. But I have a side group here. So I have a side group here. So I need to know, because now I've used this movement or this direction, now I can't go back this way, because when I come back is 1, 2, 3. But because I've already used this direction when I'm identifying the functional group, so I have to continue that way. So it's gonna be 1, 2, 3, 4. It is on carbon atom number 4. So it's gonna be 4. Yes. How many carbon atoms are on the side group? There, it's only 1. So it's 4 dash methyl hexane 3 on. 4 dash methyl hexane 3 on. I think I'm clear there. Can I know that you are in class, you are hearing what I'm saying? Yeah, so that maybe I might be talking to myself. Anyway, if you are in our class, let me know in the comments so that I know that you are there listening to me. Thank you very much. Okay, let's continue to the next question. The next question is saying that write down the IUPAC name of compound D. What is compound D? Compound D is this. All right, let's see. Where are we supposed to start from? Find the longest chain. So 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. You see? All of it is 6, 6, 6, 6, 6. All right. So if I count this, let me take this, this to be my longest chain. So the longest chain is 6. So I'll say hex. I can't say hexane. Why? Because it is not alcohol, aldehyde, hex. Single bond throughout. So it's gonna be an alkane. Alkane. So it means that it's supposed to end with this. So it's gonna become hexane. All right. So now this is done. So I have a side group. I have the second side group. I have the third side group. So I have 3 side groups. Yes. The first side group is 1, 2. It's on carbon atom number 2. The second side group is on carbon atom number 2. 1 is carbon atom number 2. Carbon atom number 2. 3, 4. The third one is on carbon atom number 4. But if I come from this side, 1, 2, 3 is on carbon atom number 3. So I take the shortest, which is 1, 2. So I'm gonna say now we're gonna do the same method we said. So the longest chain is hexane, hex, and then I add an, which means alkane. All right. That's it means. But I have the first side group and the second side group. First side group is meth. So let me write here meth. Because the side group I add YL. The second side group still is meth. I say meth. I add YL. Then the third side group is eth, 2 carbon atoms. So I'm gonna say the third side group is eth. I add YL. So it means that the first side group is on carbon atom number 2 and carbon atom number 2. Good. So it is 2 dash. Even this one is 2 dash. And then now the second one, the third one is on carbon atom number 4. So I'm gonna say 4 dash. If the compounds or the side groups are the same, so I combine them and I use the common name. I combine them and I use the common name. I'm on live. Gamba Kenny. 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 Huh? Labayo. Labayo. Bw'oba tolaba kisumuluzo jangu okime ekisumuluzo awo ne. Nowano ekisumuluzo ne ninawo kamayiki. Naye mu kamayiki mwekali. Ne? Kale. Sorry for that. You're saying that so now we combine them and then we form one name. So it's meth. So because they are two, so I'm gonna say dimethyl. I see? Yes. So it is dimethyl. So now, because I said it's dimethyl, it means that there are two. Therefore, I have to combine them. And then I'm gonna say the first one is on carbon atom number 2, 2, 2 dash dimethyl. Then I go to the last step. It is meth M and E. Which one is first? Is it M or it is E? The answer, you don't take this die because this is just to show how many are they. You go with the common, the real name. M and E, which one is first? The one which is first is E. Therefore, when I'm writing, I'm starting with alphabetical order. So I'm gonna say is 4 ethyl dash 2 comma 2 dash dimethyl hexane. 2 4 ethyl dash 2 comma 2 dimethyl hexane. That is how we are supposed to write it. Yes. Let's go to, if you have any challenge with the nomenclature, let me know. Let me know so that I deal with that. Maybe I designate a full lesson on that of nomenclature, and let me know which homologous series where you have the biggest challenge for naming these organic compounds. Let's go to another question. Another question, they are saying the question they're saying that compound D, we are done that. Write down the name and the formula of each product formed during the write down the name and the formula of the product formed during complete combustion. When you talk about combustion, when you are burning a hydrocarbon under oxygen, oxygen must be in excess so that complete combustion can take place, or otherwise you're gonna end up forming carbon monoxide, which is a very bad thing in environment. actually it combines with, instead of the body taking oxygen, it takes carbon monoxide, and then you end up uh, having no oxygen in the body, and then you are most likely to have stroke, shortage of oxygen in the brain, and then you become weak. Yeah. Anyway, that's life science. We are not in life science. We are in chemistry. All right. Anyway, let's continue and then say that complete combustion of compound D, because this is a hydrocarbon. Yes. Whenever you burn a hydrocarbon are compounds which are made up of carbon and hydrogens only. So because it is a hydrocarbon, the product is always the same. That is carbon dioxide and water. That's all. So the products here we are expecting you to say is water, H2O, and the carbon dioxide. Yes, so it is water and the carbon dioxide. So that is what you are supposed to use. Second, right? Gamba, Mr. Sam. Eh? Eh? Agambye agenda kola saa 12. The next question is they're saying that write down the structure formula of compound B. What is compound B? Compound B, where is it? Compound B. When they say compound B, they're saying the structure formula 2-methyl butanoic acid. Eh? Okay, yeah, they are looking for that 2-methyl butanoic acid. So that's what they are looking for. So they're saying they write down the structure formula of that compound. Okay, let me read it and then write down the name and the formula of each product formed during. Oh, here they said the name and the formula of compound formed during combustion. Yes. Okay, this is water. Then you write the formula. Then carbon dioxide. Write down the structure formula of compound B. Structure formula. If you are writing the structure formula of this 2-methyl butanoic acid, 2-methyl. So it means that 2-methyl butanoic acid. But is 4. 1, 2, 3, 4. Carboxylic acid. Yes. And then yeah. Yalla. So like that. But they are saying 2-methyl. So it means that when you're counting from the position of the functional group, that side. You can't count from the side. So 1, 1, 2. So the methyl is here. So it becomes like that. The structure formula, that's what they're looking for. Then you put hydrogens everywhere. Then you go to the next question. They are saying that yes, in the laboratory. Okay, they're saying that write down the structure formula of compound B, and we're done. Chain isomer of compound A. Chain isomer of compound A. Chain isomer of compound A. If you look at compound A, they are saying chain isomer. Compound A is an alkene. When you talk about chain isomer, it means that you are supposed to change the position of the side groups, or you can make it straight chain because this is a branched chain. So basically, that's what all the you can even change the position of the double bond. Still, it is fine. It has changed the chain. All right. So here in this case, you can say that you can bring this to this side. And then you say 1, 2, 1, 2, 3, 3, 4. 1, 2, 3, 4. Yes. Then you put a double bond anyway. Double bond anyway, and then now you make it to have full bonds. 1, 2, 3. Yeah. So that is a chain isomer. Simple. As simple as that. Or you can change this and you put the double bond here. And then you remove this and then you put a hydrogen here, and then yeah, so you play around with the hydrogens as long as each carbon atom is having 4 bonds. Yes. So I think I'm done with that question. Then they are saying that in a laboratory assistant uses bromine water. So what is the function of bromine? The moment you say bromine water, something must come into your mind. Bromine water is an indicator which is used to identify whether the compound is saturated or unsaturated. So when you're using bromine water, we identify whether the compound is saturated or unsaturated. If the compound is saturated, it means that it has a single bond throughout. It will not decolorize bromine. But if the compound, remember bromine is red in color. You understand? So if you have unsaturated compound like alkene or alkyne, yes, yes, then you add bromine, what's going to happen is going to be, this one's going to break. These are hydrogens, don't forget. And then this bond which broke, you're going to have a bromine here, and you're going to have another bromine there. That's all. So it means that the bromine which was red is going to become colorless. Why? Because this molecule which is formed is colorless. So whenever they talk about bromine water, what comes into your mind? It must be that you are going to deal with the saturated compounds and unsaturated compounds. Saturated compounds, when you add bromine, the bromine will remain red. But unsaturated, yes, compounds, when you add bromine is going to turn into colorless. Why? Due to this reaction we have seen. All right, now let's go back to our question and see what story are they telling us, because we have already got the idea what is going to happen with bromine water. All right. They are saying that um, bromine, a laboratory assistant uses bromine water to distinguish between compound D and A. She added bromine water to sample of each in 2 different test tubes. She observed that one compound decolonizes. Now, once you see this, one compound decolonizes, your mind must be that this must be a double bond or is a triple bond between carbon atoms. Bromine water immediately, while other only reacts after placing the test tube under sunlight. So it means that when you put it under sunlight, it undergoes, yes, substitution. But here it does not undergo substitution, it undergoes addition. Yes. So letter D or E of compound will immediately decolorize. So now D or E. Where is E? E is, you are saying but2-ene is a double bond. Then D is single bond. So it means that D is the one which is going to decolorize after, sorry, you're saying compound D or D will decolorize immediately. Yeah, it is going to be a double bond. So it means that the answer here is going to be E. Yes. So E is going to decolorize immediately. And then they are saying that name the type of reaction that takes place in the test tube according to compound D. According to compound D. So what happens on compound D? So because it is let me just show you with just a simple example. That is an alkane. So if you add bromine with the under sunlight, what's going to happen is this compound, the hydrogen which is here, is going to be replaced. So this one is going to break. Yes. So once it breaks, so it's going to have that, and also that one is going to have this, and then this one is going to go and then replaces the hydrogen. And then now you're going to have a compound with this. that. So that's what you're gonna have. Yes. So basically, that's gonna happen, and then at the end you're gonna have hydrogen bromide. It means that basically what happened here is the substitution. But compound D, because it is an alkane, it was like this, so we just added. So this is addition, while this one is the substitution. So if it is a double bond, when it decarboxylates immediately, it must be a unsaturated compound, so it is the addition. And then if it is a single bond, you have to expose it to light for the reaction to take place, then it is the it is substitution. So name the type of reaction that takes place in compound D. So we have seen it, that is substitution. Or because you are adding the halogen, so it can be halogenation. Or because you are adding a bromine, you can say bromination. Yes, a substitution because you are substituting the hydrogen with the bromine, or it's a halogenation because you are adding a halogen. Bromine is a group 7 element, or bromination because you are being specific now. You are adding bromine on the compound. Structure formula of compound of organic product formed in the test tube containing E. Where is E? E is this, is but, which means but 2. But, it means that it is 3. So it means that what's going to happen is this. They're saying but 2. But means 4. So it's going to be double bond there. Yeah. So, yes. 1, 2, 3. Gonna be 1, 2, 3, 4. Cool. 1, 2, 3, 4. Cool. 1, 2, 3, 4. Cool. 2, 3, 4. Sharp. Ah. Yes. So basically, that is it. And now, when you add the bromine, so what's going to happen is going to be CH, yes, C, yes. Now, this one is going to be replaced with the bromine and then a bond. This one, another, remember it breaks. Another half is going to be filled with bromine, and then you have that. So basically, and then you put hydrogens. Don't forget to put hydrogens, ne? Don't forget. Sorry. So basically this becomes the structure formula for that organic compound. Yes, let's go to the next question. The next question is the structure formula. So basically, if you look at this, is the same question. Take a screenshot and then you do this for me. Yeah, do this for me. Do that question for me. At least, yeah, send it on my WhatsApp number. If you get a challenge anywhere, so that I can maybe help you out. But if you are fine with it, then let me know that you are fine with it in the comment below, and then you see that at least, yeah, the people I'm teaching, they are progressing. And then we have another question which is dealing with the reactions. This question is dealing with the reactions. So I know that reactions, when it comes to reactions, people are always having problems with the reactions. People are always finding problems with the reactions. So because people are always finding problems with the reactions, therefore, let's do some justice, ne? And then we deal with this question of reaction, and then after that, we can go to the properties. All right. Define the term functional group. What is a functional group? Basically, functional group is It could be a bond. It could be an atom. It could be a group of atoms. It can be a bond. Why do we say bond? Alkane, alkene, alkynes. Those are just bonds. Atoms, it could be just atoms. For example, haloalkanes, group 7 elements is only one which can make that reaction to react that way, an atom. Group of atoms, alcohol. Alcohol, yes, it could is OH, which determines it. Ketones is OC, which determines it with the hydrogen. For the case of aldehydes, carboxylic acid, COOH, group of atoms. What do this bond, these atoms or group of atoms, what do they do? They determine how these reactions look like and how do they react. Basically, the physical and the chemical properties of these compounds. So is a bond or an atom which a bond, an atom, or a group of atoms which determines the physical and the chemical properties of the organic compounds. That is the functional group. I think I'm clear. Yes, I think you are getting it. Ne? Yes, so they must determine the physical and the chemical properties of these organic compounds. Yes. You're done with that? They're saying that structure formula of functional group of aldehydes. Structure formula of the functional group of aldehydes. Remember aldehydes, they are at the terminal. You see? Group of atoms, you see? Group of atoms. So aldehydes, they react the way they react because of this group of atoms which you see there. You understand? Yes. Then the next question is name the functional group. Okay, we are done with that. The IUPAC name of organic compound 2,4-dimethyl. Name the functional group of, oh, we are done with that. Oh, no. Name the functional group of carboxylic acids. Carboxyl. That's the functional group. So the functional group is carboxyl. That's the functional group of the carboxylic acids. Functional group of esters, we don't usually teach it at this level. IUPAC name of organic compound is 2,4-dimethyl hexane 3-on. For this compound, write down the homologous series to which it belongs. They are looking for the homologous series, not the functional group. The homologous series, the moment you say on, so it is a keton, on, yes. Whatever is here, we don't mind about it, as long as they say the homologous series to which it belongs. Yes. Structure formula. Okay, let's sort it out. Hexane. So it means there are 6. 1, 2, 3, 4, 5, 6. It is on carbon atom number 3. 1, 2. They're saying on the oxygen is on carbon atom number 3. We say this, then it means that it's 1, 2, 3. So it is here. And they're saying that 2, 4. 2 on the carbon atom number 4. Now we use the same direction because we use this 1, 2. You have a methyl there. And then 4. 1, 2, 3, 4. You have another methyl. There's a methyl? Yes, it's a methyl. Yes. So after that, you fill in with the hydrogens. 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Basically you put hydrogens, guys, don't forget that. It's just that no time for now, but you put the hydrogens there. We go to the next question. They are saying that homologous series to which it belongs. We are done with that. The structure formula. Write the structure formula. Homologous series. We are done with that. We are done with that. Write down the IUPAC name of the following organic compounds. The IUPAC name. The IUPAC name of these organic compounds. Yes. All right. Let's start. 1 2 3 4 5 6. Okay, 1 2 1 1 2 3 4 5 6, but there is a bromine, so you have to use this. 1 2 3 4 5 6. 1 2 3 4 5. No, so it's 6. The longest one is 6, but it's single bond throughout, therefore it's gonna be hexane. Now I need to find, if I say 1 2 3 4 5, 1 2 3 4 5 6. So if I make this one the longest chain, 1 2 3 4 5, even this one has the longest chain, is fine. So this and this are side groups. So now we need to find out the what, the compound is name. All right, let me rub off here so that we can I want to show you there's something very important here you need to take note. Very important, because it might make you confused. Okay, it's hexane. So now if I say 1 2 3 4 5 6, so let me say methane, meth, yes, YL, cool. If this one is meth, YL, cool. Then this one is eth, YL, cool. Now I need to know the position. When I'm coming, there is this bromo also. Bromo. Yes. So if I'm counting from the side, it's gonna be 2. This one meth is gonna be 3. 1 2 3. Gonna be 4 5. 5. Even this is 5. So it's gonna be 2 3. And then what about when I'm coming from this side? It's gonna be, the first one is 1 2. It's gonna be 2 2, because it's 1 2. So it's gonna be this one. So 1 2 2 2. And then 1 2 3 4. It's gonna be 4. Yes. Then 1 1 2 3 4 5. So it's gonna be 5. Yes. Now add this and also add this. See, this is 2 plus 2 is 4, plus 2 is 8. 8 plus 5 is 13. 2 plus 5 plus 5 is 10, plus 3 is gonna be 13, plus 2 is gonna be 15. See? So we take the lowest. Are you gonna take this or we're gonna take this? So the answer is we're gonna take this, because this is 13. When you add all of them, you form 13. Now you don't stop there. Don't forget to write them here. Now, once you have known that, okay, I've taken this. So this one, I scoop them out. So now, once I know that, now I follow the functional, the alphabetical order. But because these two are the same, so I will use the word dimethyl. And then now M, E, and B, which one is first? A, B, C, D, E. A, B, C, D. So I'm going to start with B. So I'm going to start here and I say 5 bromo dash 4 dash ethyl, yes, dash 2 comma 2 dash dimethyl hexane. Am I clear? Am I clear, people on live? Are you getting it? Yes. So it's gonna be 2 bromo 4 ethyl 2 dimethyl hexane. That's how we write that. Then we go to they're saying write down the IUPAC name of compounds. Now, what about this compound? Should I give you it as a homework? Sorry. So still we're gonna use the same method, but this one is a little bit simple. Let's see it, and then we say that uh, it's 1 2 1 2 3 4 5 1 2 3 4 5. So the longest chain is 5. So it's gonna be pent. But if it is pent, if it is pent. So if it is pent, but it has these 3, so it is alkyne. Alkyne. So it means that I'm going to add Y, that alkyne. But what's the position? What is the position of this? The position of this is going to be 1 2. So coming out of number 2. Well, this one is 1 2 1 2 3. So coming out of number 3. So I'm gonna go with 2. So it's gonna be pent dash 2 dash yin, pent 2 yin. And then now I have the side group here. It's 1 2 3 4. So carbon atom number 4. So it's gonna be 4. It's a methyl dash methyl pent 2 in. 4 methyl pent 2 in. That's how we write it. So now let's go to the properties of organic compounds, and then we'll end up with the what? With the reaction. Let me just deal with one question of properties, and then we go to the reaction, and then we see what to do next. Yes. They're saying that group, I discussed properties yesterday. Define what is boiling point. So basically, when you talk about boiling point, you're talking about compounds. Compounds only boil when the vapor pressure is of that substance is equal to the atmospheric pressure. Remember, the atmospheric pressure is 1 atmosphere, or 78 millimeters of mercury. 78 millimeters of mercury. 78 millimeters of mercury. Yes. Why do we say millimeters of mercury? Because that's what you use in the thermometer. Yes, is it thermometer? No, not thermometer. Barometer. Barometer is the one which is used to measure the pressure. Yes. All right. They're saying that the curve P, for curve P, write down the conclusion that could be, what did they say? Let me see. Saying the relationship between boiling point of point and the number of carbon atoms in the straight chain molecules of alkanes. Carboxylic acids, alcohol are investigated. Alkanes, definitely alkanes will have a low boiling point. Carboxylic acid will have a higher boiling point, and then alcohols will have a minimum boiling point. Why? Basically, here you have to look at the London force, dipole forces, and then hydrogen bonds. All of them, they have London forces. Why? Because they have carbon atoms. They have a specific mass. These two, they have dipole forces and the hydrogen bonds. However, alcohol has one side of hydrogen bond, while carboxylic acid has two sides of hydrogen bonds. Hence, it will require more heat to break those bonds so that they can evaporate to start to boil or to have maximum vapor pressure. So they're saying that for curve P, write down the conclusion that can be taken, that can be drawn from the above results. If you look at curve P, here is curve P. So what can you say? What can you say about curve P? Curve P. So if you look at curve P, you can see that as the number of carbon atom increase, the boiling point, yes, as the number of atom increase, the boiling point also increases. So when you're comparing, you have to talk about the two factors. As the number of carbon atom increase, the boiling point also increases. Yes, so basically that's what you can talk about, but you can also talk about it in the reverse way, that as the boiling point decreases the carbon atom from 7 to 1. As the boiling point, no, 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 no. What depends on the other? What depends on? So as the number of carbon atom increase, the boiling point also increases. You understand? So or boiling point increases with the number of carbon atoms or the chain length. Don't say as boiling point increases the number of carbon atoms. No, no, no. Boiling point does not cause the number of carbon atoms to increase, but the number of carbon atoms cause the boiling point to increase. Yes. Then we go to, so as the number of carbon atom increases, the boiling point, you see that the boiling point increases. One carbon atom is 100, two carbon atoms is 200, whatever. Three carbon atoms is 2 point something. Six carbon atoms, you see that is 3 point something. So as the number of carbon atom increases, the boiling point also increases. Identify the curve PQR that represents each of the following alkanes. Remember, alkanes we say that has the lowest boiling point. So this curve, you have to take note because they can bring a curve for vapor pressure. So it means that if this curve was for vapor pressure, then R would have been the alkane because it has the maximum vapor pressure, the highest vapor pressure because of the low boiling point. But because it's dealing with the boiling point, then P becomes the alkane because it has the lowest uh, vapor pressure, sorry, the boiling point. Alkane, carboxylic acid has the highest boiling point because of the two sides of hydrogen bonds. It has the London force, dipole force, and then hydrogen bonds, but two sides, while alcohol only has one side. Hence, its boiling point is higher than that of alcohol. Then they're saying that The type of intermolecular forces, we are done with that. Sorry, not that one. Explain the answer Q, this one, referring to the type of intermolecular force of attraction found in alkane, carboxylic acid, and alcohol. We have explained them. Relative strength of the intermolecular forces and the energy needed to break these bonds. So basically, I've talked about them. That we say that between alcohol, so alkane is P, and then carboxylic acid is R. All right. So now, if you're explaining this between alcohol, yes, between alkanes, yes, we have London forces. Or all alkane, carboxylic acid and alcohol, all of them have London forces. But alkanes only have London forces. So alcohols have London force. So in addition to London force, they also have dipole, and they also have the hydrogen bond, but with one side for this hydrogen bonding. For the case of carboxylic acid, in addition to London force and dipole force, they have what we call hydrogen bonds also, but with two sides of hydrogen bonding. So the bonding are there with the two sides because of the number of oxygens this molecule has. So it has two sides. Hence, it will require, or the intermolecular forces of attraction for carboxylic acids are greater than alkane and alcohols. Hence, it will require more energy to break these intermolecular forces so that these compounds can move freely. So basically, that's how you can explain it. Should I repeat it? I said, alkanes only have, if you look at these alkanes, alkanes only have London forces. Alcohols and the carboxylic acid also have London forces. But on addition to London forces, for the case of alcohol, they also have what you call dipole forces and also hydrogen bonds, but with one side for hydrogen bonding. And then carboxylic acid, on addition to London force and dipole force, it has hydrogen bonds with the two sides of hydrogen bonding. Therefore, the intermolecular forces of attraction for this carboxylic acid is higher than, or is the highest among the three. Yes, so it will require more energy to break these intermolecular forces of attraction for carboxylic acid so that the compound can bind. Yes, so that's how we explain that. Here is another question. Yes, we only have two questions to go, meaning that in the next 15 minutes, we will be done. Is compound bisaturated or unsaturated? Remember, saturated compounds are compounds which have single bond between carbon atoms throughout, while unsaturated compounds are compounds which have a double or a triple bond between carbon atom. Yes, between any two carbon atoms. Yes. So, is compound bisaturated? CH3, CH3. This one obeys the alkane general formula. Therefore, it is saturated. Then they are saying that compound boils at, consider the boiling point of A to E, given a random order, and then use the where applicable answer the question that follows. Okay, let's see. Write down the boiling point of C. Where is C? C. Basically, this, and this. All these three. Are they three? They are four. They have London force. But London force increase with the number of carbon atoms. Therefore, this one will have the highest among these. But this one will have more because of however much it has low number of carbon atom, but it has dipole force and hydrogen bond. Therefore, the boiling point has to be the highest among all. So if you come here, the highest boiling point is this. Don't forget that this is negative. Yes, so negative is this one, 0 is higher than this. Yes, so compound C, so it is not the highest, it's so we're gonna look the lowest, so it means that this must be A, B it must be the next, C it must be this, and then D it must be this, and then E it must be that, based on what we talked about in terms of intermolecular force of attraction. Explain the difference between the boiling point of C and E. C and E. C only has London forces, so it requires less heat to break these bonds. So it means that the boiling point is low. While E has London force, dipole force, and hydrogen bonds, which require a great amount of heat to break these bonds. Hence, the boiling point is high. So yes. Then we have explained the difference between, okay, we have seen that. Does vapor pressure increase or decrease from A to D? A to D. So as we are going, because this one has low boiling point, high boiling point, the vapor pressure is gonna keep on decreasing. The higher the boiling point, the lower the vapor pressure. How will the vapor pressure of compound, how will the vapor pressure of compound of 2-methylpropane compared to vapor pressure of D? 2-methylpropane. Ne? How will the vapor pressure? It will be higher than or lower than 2-methyl. How will the vapor pressure of 2-methylpropane compared to the vapor pressure of compound D? 1, 2, 3, 4. So it's just a branched chain. A branched chain. So in this case, if the compound is branched, the boiling point is lower. You understand? The boiling point is lower, and then the vapor pressure is high. So in this case, because this is a branched chain, therefore the vapor pressure is gonna be high, and the boiling point is gonna be low. Sorry. So that is it. Let's go to the last question. That is reactions. Reactions. I hope you like this question. Ne? I hope you like this question the way I like it. Actually, the way I love it. Anyway, let's continue. We are saying that the following diagram below show propane prop 1 in can be used to prepare other organic molecules. All right. We are hearing what you are saying. Yes. So, I think I was supposed to add one question here for you guys so that at least, yes, okay. Okay, we'll see what to do. They are saying that write down the reaction, the type of reaction represented by A. What is A? Propane 1. So you're from double bond from unsaturated to saturated. So that is additional reaction. From unsaturated to saturated, that is the addition or reaction. What are you adding? You are adding hydrogen. So it can be hydrogenation or addition reaction. So that's D from compound a major product X to this, but this can go this. Okay, now we got it. Now here is supposed to use what called Markovnikov rule. Markovnikov rule. So I hope you know what you call Markovnikov rule. Markovnikov rule. So Markovnikov rule means, or it shows that when you have a compound, actually unbalanced compound, and this compound has you want to add a hydrogen or a haloalkane, not a haloalkane, a hydrogen halide, like hydrogen bromide, hydrochloric acid, yeah, those ones. Yes, the carbon atom with the fewer number of hydrogen will take the bromine, and the carbon atom with the more number of carbons will take the hydrogen. So let me show you. Let me write this. 1, 2, 3. Yes, they're saying that double bond is there. So if you put it's gonna be that, it's gonna be that, it's gonna be one hydrogen, it's gonna be, and then it's gonna be 3. So Markovnikov rule says that now you have hydrogen bromide. Where is the hydrogen gonna go and where is the bromide? The carbon atom so it's gonna be using these two carbon atoms. The carbon atom with more hydrogens is gonna take the hydrogen. Therefore, the hydrogen is gonna go on this. And then the carbon atom with the fewer hydrogen is gonna take the halide or the halogen or the OH, depending on which compound you are using. Therefore, now here I'm gonna have CH3, yes, CH, and then now the bromine is gonna be here on this. So the bromine is gonna be here, and then CH3. So basically, that is the major product they are talking about, compound X. So compound D. So now I want compound D going back. So I have to remove this bromide I've removed. So therefore, the answer is gonna be yes. What are you trying to do there? You are trying to eliminate. Yes. So when you eliminate, so you are eliminating. You are eliminating hydrogen and bromide, and then you go back to this. But what are you eliminating? You are eliminating the hydrogen and the bromide. So because this hydrogen and bromide and eliminate means D, so it's going to be dehydrohalogenation or dehydrobromination, depending on basically which one is it. So but prefer saying dehydrohalogenation. Yes. Then, because that is general, then they're saying that compound F, reaction F, yeah, reaction F. These reactions you just need to understand. I think I should make a full class which just trying to explain only these reactions. Yes, this to this. Alcohol as a major product still is gonna use the Markovnikov rule. It's going to use the Markovnikov rule. So here it's going to be CH3, CHOH, CH3. Yes. So now that's the major product. And then now once it is, they're saying that compound F, reaction F, from this to this. Because I'm removing the OH to bromine, therefore it's going to be substitution. What I substituting is I'm removing the OH, and then I'm putting there the bromine. Therefore, it is a halogenation or bromination. So substitution will work better. Or halogenation is still fine, or bromination. Name the formula of a catalyst needed for A. Where is A? Which catalyst? When you are changing from here to there or here to here, we use the same catalyst. Yes, we use platinum. Platinum is the best. nickel, palladium. Yes, so platinum, nickel, palladium is all of them are good for that. But I prefer platinum. Yes, because we usually use it in many reactions. Okay, they're saying that name the formula of the catalyst. I'll put the catalyst there. They say the formula. Name the formula of inorganic reagent for reaction B. Reaction B. Where is reaction B? Oh, alcohol is going to this alkene. So it means that dehydration. So whenever you are talking about dehydration, we use conc, sulfuric acid. They said the formula. They didn't say the words. They said name or formula. So NA is fine. So it is conc is sulfuric H2 sulfuric acid. The type of additional reaction represented by C, the type of additional reaction represented by C, C, you are having alkene to alcohol. So if you have alkene to alcohol, you're adding water there. So it is gonna be hydration. You are putting OH on it. So it is hydration. IUPAC name of compound X. Where is compound X? Yeah, it's here. 1, 2. So bromine is on carbon atom number 2. So it's gonna be 1, 2, 3. So it's gonna be propan. Yes, but bromine is on carbon atom number 2. So it's gonna be 2 bromo propane. Yes, 2 bromo propane. And then now they're saying that use the structure formally to write down the balanced equation of compound B. The structure formally to write the balanced equation of compound. So basically here, because these are reactive from alkene of compound B, these are just reactive. They are reactive. So this to this, so it means that with sulfuric acid, so you just have to use the general formula. You're saying the structure formula. So I'm going to say that because there are three, maybe 1, 1, 2, 3. And then remember this is the alcohol. Yes, yes. Don't forget to put the hydrogens there. Yes, and then remember that we use the sulfuric acid conc and then we dehydrate it. So once we dehydrate it, we're gonna have a double bond, a double bond, a double bond. Yes. This one is not there. 1, 2, 3, 4. Yeah, yeah, yeah. Plus H. Remember they said the general for the structure formula. So you put hydrogens everywhere. So that is how you talk about that reaction. Actually, this kind of reactions is not appetizing. I know that these are one of the things which make the student who be hating chemistry and stuff like that. But as long as you practice it, practice it, yeah, you understand. If you get a challenge, let me know. Let me know. I always try to help you out. And if you are among our subscribers, that subscription of join to access the books, you'll get maximum attention. Yes, those people who are joining that, they just pay 20 rand, 20 rand. So just join, and then yeah, so that you get anytime you need help, we always help you. Yeah, except when we are sleeping. Yeah, we sleep around 10 o'clock. Yes. So and then very early in the morning, still we reply to you. All right, let's continue to the last question. They are saying that both reaction D and E take place in presence of the strong base. State 2 conditions. State 2 conditions, yes, that will favor those reactions. D and E. D, where is D? D from this major product to this, and then E from this to this. So which conditions are taking place there? Basically, you need a high temperature and a concentrated base. Yes. Here, when we talk about the concentrated base, it is supposed to be a mineral base. A mineral base like sodium hydroxide, potassium hydroxide. Yes, a strong base. Yes. Lastly, I'm just going to talk about esterification, formation of esters. Don't forget that when we talk about esterification, here we talk about esterification. Esters are formed as a result of alcohol plus carboxylic acid in presence of conc sulfuric acid, and then you heat, and then after that you get the ester plus H2O, which is water. So you can think any kind of alcohol, maybe ethanoic ethanol, okay, CH3, CH2, OH plus maybe carboxylic acid here. In this case, is gonna be maybe uh, uh, ethanoic acid still, CH3, CH2, CH3, CH3, COOH. Sorry. Then sulfuric acid, conc, heat, and then you form CH3, CH2, or C, CH3. Yes, and then plus. Yes. Now let me write the structure formula for each so that you understand better. CH3, so it's gonna be like that. Then plus this, then giving you conc sulfuric acid. Yes, in the heat, your heat. Now, how does this ester? Obviously, you know that one for water, so it's gonna be like that. And then, how does this ester form? So this one is gonna lose the hydrogen, and then this is gonna lose the hydrogen and oxygen, and these two they form that water we are talking about here. Then now the remaining one they combine, and then you form this C. Yes, CH. So now this combines with this side. So that's why I'm saying that you have dash C, this one, and then O, and then C, CH3, like 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 that, and then you put the hydrogens. This the compound, the esters, they have what called a fruity smell. I think, guys, I've tried to discuss most of the things or the ideas you might find in exam tomorrow. I wish you the best, those who are writing tomorrow, because you told me. And then in the evening, after 6 o'clock, yes, we're gonna come with vertical projectiles. Yes, those projectiles, because many students they asked me so that they can help them with the projectiles. Yes, so sir is preparing for you to come for vertical projectiles, so please keep on our YouTube channel. Don't forget to subscribe, like, and share to others for our daily new videos every single day. Yes, every single day you will be being helped here on ThunderEDUC. Thank you very much. Stay blessed. M.SAIDI as usual.